So here's some sources that I rely on quite a bit. This is the Climate Science Special Report that came out in 2017 and the National Climate Assessment in 2018, and I was heavily involved with the second one there. And also there's some state summaries that are associated with those, and those are in the process of being updated. So some of the numbers are a little bit behind, but the overall effect is still the same. So we'll talk about some of the contents in there, as well as some other sources for climate information. And so, of course, this is obviously being recorded, but I can also share the actual PowerPoint slides as well. So we talk about the greenhouse effect a lot. And basically, the short answer is that it's a natural phenomenon. In fact, the Earth would be much colder if we didn't have an atmosphere with greenhouse gases in it. As the sun beats down on the Earth, it warms up the Earth's surface and the atmosphere. And a lot of that escapes back into space, but a certain amount of it gets held back by the greenhouse gases in the atmosphere, making us much warmer. So for us overall, if we didn't have any greenhouse gases, our average temperature would be about 0, and it would fluctuate quite a bit from night and day, whereas it gives us a more moderate 60-degree average with the greenhouse gas layers. So that is a natural feature of the atmosphere, and thank goodness it's there. But the problem is that we're adding to it. So there's such a thing as too much of a good thing. This is the reconstructed CO2 levels during past several ice ages and warm periods over the last 800,000 years. And you can see it cycles back and forth, runs from about 175 to 275-ish, up to 300 there, for hundreds of thousands of years. And then in the last 50 years or so, it has skyrocketed. And this graph that came out in 2018 shows it at 407 parts per million, where I think the last numbers I checked in February, it was 413 parts per million. So just in the span of the last couple of decades, we've seen this major increase. There's no secret where it's coming from. It's the burning of fossil fuels. If we look at the impact on temperatures, we can reconstruct temperatures pretty far back as well, based on not only the historical record, but proxy data from other sources. That's a whole other field of expertise there. But if you reconstruct, for example, the last 1700 years, it kind of puts the current warming in a better perspective. And then you see the red on the right-hand side of the graph there. That's the thermometer-based records. And then before that is the reconstructed records. And you can see there was some other warm periods, and we had the little ice age, and those caused quite a bit of differences in our temperatures. But if you look at the last couple of decades, they are head and shoulders above what we've seen in the last 1700 years. In fact, really to see temperatures like we have right now around the globe, you'd have to go back about 125,000 years. And at that time, that was caused by different mechanisms than what we have now with the greenhouse gases. It was actually changes in the orbit that caused the Earth to be warmer at that time. So you can say that this is the warmest we've been in a long, long time based on the historical records. If you look at the more recent period from 1880 to present, you can see that this is the average global temperatures. And in the 1880s to about 1940, they were in the blue. So they're below the long-term average. If you averaged all the data, pretty much everything below before 1940 was below the long-term average. Everything since then is above the long-term average. And probably the most striking feature of this graph is the warming that we've seen since the late 70s and early 80s. That it's just a continuous upward march in global temperatures. And in fact, if you add on 2019, our latest year data, it was the second warmest year on record. And superimposed on this is the greenhouse gas line. So there's the carbon dioxide levels in parts per million using the right axes there. And you can see that it's pretty much lockstep with the rise in temperatures there. If we look at all the factors that have gone on into these changes in the 20th and 21st century, we look at volcanic activity, solar activity, orbital changes, all the natural drivers really don't do much. We've been able to model temperatures with and without those kinds of things, and the volcanoes and solar and orbital factors. They give us some year-to-year variability. That volcanoes in particular can cool us off for a couple of years, but that's about it. So really the natural factors are not or what's driving our increase in warming. And it's only after you add in the greenhouse gases that you see a warming in the models that matches the observed trend. So back in the day, back when I first started 35 years ago, we were back in the line there around 1984. And at that point in time, it had warmed, but it really wasn't all that evident that all of the warming was being caused by human-induced changes, nor was it really obvious how much warming we were experiencing. But in the last 30 years, we've seen much more warming, and based on the model research and other bits of evidence, we are now certain that all of the warming that we're seeing since in the last 30 or 40 years has been human-induced. So that part of the question has been answered in that we are the warming. Now, it is a global phenomena. If you look around the world, the world's oceans and land masses are warming. Land masses warm a little bit faster, and that's kind of expected. Water is much harder to warm up than the land surface. So you see places like Europe and Asia have warmed up quite dramatically. In the Americas, we've had some major warming in South America, especially in the Amazon basin. And in North America, in particular, Canada and Alaska has warmed quite a bit in the last several decades. And this is based on data from a more recent 1986 to 2016 period versus an earlier 1901 to 1960 period. So kind of like the first half of the 20th century and the more recent period there. So pretty dramatic warming. You will see, though, there's an area in the southeastern United States that has not warmed as much as the rest of the U.S., and we're kind of on the edge of that. So the National Center for Environmental Information has this thing that they do, actually it's every month, it's called the State of the Climate. They also at the end of the year do an annual State of the Climate report, and it details the trends that they're seeing and also the impacts around the world. So well, we could spend quite a bit of time just looking at this one graph, but I'll just highlight a few things in 2019. One is that Alaska had its warmest year on record. The ice extent in both the Arctic and Antarctic regions are declining. Africa has had its third warmest year on record. Asia has third warmest on record. In fact, Asia, 2015 and 2017 were also their warmest years, so right on track there. And of course, Europe has had quite a bit of trouble lately with really hot weather as well. So the impacts are truly global in nature on this phenomena. If we zoom in on the United States and we look at that same period as we looked at on the global temperatures, the most recent 1986 to 2016 versus the early period of 1901 to 1960, and look at that difference, you can see that in the United States, there's quite a bit of warming taking place, especially to the north of us and to the west of us, and also in the northeast. We're kind of in an area that's seen warming, but not as strong as those other places. So if you talk to somebody that's from Minnesota or California or Washington or Oregon, they'll have a different take on their experiences of climate change over the last 30 years versus somebody in Alabama or Mississippi. It's just, it's not happening everywhere at the same rate or in the same ways. But for Illinois, we are seeing the warming, but it's just not quite as noticeable as some of the other places. The other thing is that if you look at the two bottom panels there, winter temperatures have actually increased much more than summer temperatures. In fact, winter temperatures are probably the most pronounced part of the warming that we see here in Illinois, and also in many places around the U.S. This winter I heard a lot of complaints in years past about ice fishing in Minnesota and snowmobiling and those kinds of winter activities that really get put on hold from these mild winters. So they do have an economic impact that isn't always positive. Summertime temperatures have not changed as much. In the West, where it's drier, summertime temperatures have soared. But once you get into Kansas, Nebraska, and eastward, we see that they really haven't changed that much. And in fact, in some places, summer temperatures have actually cooled a little bit. We'll go into detail in that in just a minute. So let's just kind of give you a broad picture of what's going on in the United States right now and who's getting hit the most by this. If we look at projections by mid to late century, in the top row there we have the mid-century mark. So it's about 2030 to 2050, so it's not that far away. And in the Midwest, we're expecting increases of about 4 to 5 degrees Fahrenheit over that time period, both from the low and high scenario. So the low scenario is where we try to do good and reduce our emissions. The high scenario is pretty much keep doing what we've always done. And so probably how it will really play out is probably somewhere in between these. The bottom panel here is the end of the 21st century, and there you can really start to see big differences between the low scenario and the high scenario. So mid-century, there's not much difference, but by the end of the century, the higher emission rates really start to compound. It's like compounding interest. They really start to build up, and the effects really start to build up. So by the end of the century, we could see warming in the Midwest really closer to the 9-degree level than the 5-degree level at the lower scenario. And I would say, looking at these scenarios for the last 30 years, that for the Midwest, they really have not changed that much. If you look 30 years ago at some of the initial model runs, they were pretty much showing the same thing, moderate warming by mid-century and a lot of warming by the end of the century. So it's been a fairly consistent message across the last 3 decades. But it's not just temperatures that are changing. When you warm up the atmosphere, you actually accelerate the water cycle. So warmer air, you get more evaporation. More evaporation, you got more fuel for passing storms, so you get more precipitation back out of that. In fact, there's an equation that you can do that'll show that for every degree Fahrenheit increase in temperature, you get about 4% more water vapor into the atmosphere. So it really revs things up. So as a result, not only are you getting more rain, but you're getting more of the heavy rain events out of these, out of the atmosphere. The other thing is kind of an additional detail in the Midwest is that we've also changed the land surface quite a bit. If you look across Illinois, 300 years ago, it was tall grass prairie, woods, and wetlands. Now it's corn and soybeans and some wheat and some other things, but it's also parking lots and cities and roadways and so forth. So we've really changed the land surface, and there's been some studies that have looked at humidity levels, especially in the July and August time frame, that we're seeing big spikes in those levels because we have this vigorously growing corn and soybean crop. So they're as part of a byproduct, you could say, of their increased yields, is that they transpire more moisture into the atmosphere. So we're seeing much higher humidity levels in certain circumstances in the summertime because of that. If you look at precipitation overall, it's a little different pattern than the temperature ranges in the United States. The central U.S., the central third of the U.S. has actually been very wet over the last century or so. This is that same scheme as before, where we look at the earlier part of the 20th century versus the more recent period. And you can see many areas have increased by 5, 10 to 15%, depending on where you are in the Midwest. So overall, the middle part of the of the U.S. has been getting wetter, and also the Northeast as well. So those areas, we've seen that pretty much around the year. So all 4 seasons have been getting wetter, including the summertime. And so this was not a big surprise. We pretty much expected as we warmed the atmosphere that we were going to see more precipitation. And by the way, the southwestern U.S. is actually getting drier. So if you look at U.S. precipitation, this is just a time series plot across the whole United States here from 1895 to present. And it's gotten about 2 inches wetter over the last century. And so it's just, it shows that while there are some years are drier, some years are wetter, there's a lot of year-to-year variability, that overall we have been getting wetter. Now in the future, I would say in general, and this is true whether you're forecasting precipitation for tomorrow or next week or next century, our confidence in precipitation forecasts are not quite as high as temperature. There's a lot more processes involved. It's just not quite as straightforward. And so therefore some of the projections of precipitation have changed over time. It used to be we thought Illinois was going to be really dry. Now the evidence points towards increased precipitation, especially in the winter and spring months, and that's part of a broader pattern across much of the United States of wetter conditions, but also a chance of being drier in the summertime. And it's kind of a toss-up here on the fall. There's a high degree of uncertainty in the fall. So winters and springs, drier summers may be more of a typical case. That may sound familiar because that's basically what we've experienced for the last couple of years, where we've had some really wet winters and really wet springs that have led to big impacts across Illinois, and then sometimes followed by some dry weather in the summertime, which can be pretty catastrophic for crops. The Climate Science Special Report for the United States that came out in 2017, they had some broad statements that they've made, some key statements. One is that precipitation is with medium confidence, they have that precipitation is likely to increase over time into the future, and that heavy precipitation events will increase in frequency and amounts. And that they have as high confidence. I'd say that I would pretty much agree with those particular comments. So if we go to Illinois, so what have we got in Illinois? We've got some really old historical records back at Fort Armstrong, which is on Rock Island. Now it's the Rock Island Arsenal. There's a museum there. And in a drawer downstairs, they've got the original records all laminated. And so this is from April 1820. In 1820, Illinois was the frontier. This was as far as the European settlers had gone so far. So they're still trying to discover what the weather and climate was like in Illinois at that time. So some of our early documentation came from Army forts, and it's usually by the fort surgeon, because they were one of the few people that knew how to read and write. They were familiar with instruments and record keeping. So it's kind of natural that they would be the recorders of weather and climate information. And just as an aside, we had a student look at these numbers and compare them to modern day values, and they're actually pretty comparable. They measured 3 times a day at 7 a.m., 2 p.m., and 9 p.m. And that pretty much gets you the high and low for the day. So they actually did a pretty good job on these. So we've looked at them a little bit. Maybe someday we'll look at them in more detail to kind of fill in the blanks there on some of our early records. But we have really solid records across the state, starting about 1895 up through present. And so for Illinois, if you look at precipitation, we've seen this upward trend in precipitation, and the trend line is about 4.7 inches per century. So we've gotten about an extra month's worth of precipitation out of the Illinois climate over time. So first part of the 20th century in Illinois was a pretty dry place, much drier than what we're used to today. It's much more common to be not only overall wetter, but to experience more wet periods, more wet years, and fewer dry years. So it has already changed the climate of Illinois. And in fact, I would say this is probably the biggest climate change message that we have in Illinois right now. Is this pretty dramatic change over the 20th and 21st century in terms of precipitation. Not only is it the overall precipitation, but we also see it in the more extreme events. So this is one measure. It's the number of 2-inch events and how those have changed over time across the state. So we just average all the states together, count up all their 2-inch events, and see how those have changed over time. In the first half of the 20th century, they're not that common, but in the second half, the frequency has almost doubled, especially in the last couple of half decades there. They're much more frequent. They also tend to occur over larger areas, and we're seeing more of what I call out-of-season heavy rain events. So we're getting more of them in the wintertime and early spring, when we don't get that bigger rainfall events in the wintertime. Usually we get them as snow instead of rain. But that's especially problematic because in the wintertime, soils are either frozen or it's bare ground in many cases. So you get a lot more runoff and a lot more erosion and flooding as a result. And speaking of flooding, we have, again, one of the biggest impacts of all of this increase in rainfall and heavy rainfall is the impacts that we've seen on agriculture and even urban areas. So we did a study a couple of years ago on urban flooding, and this is outside of the river systems. This is street flooding, basement flooding, business flooding, and naturally the Chicago area is the hot spot. But almost every state in Illinois has at least some flooding claims. This is basically based on insurance claims. And the point is, it was about a $2 billion loss over this 10-year period. So it's very substantial losses just from what we kind of would write off as routine flooding or annoyance flooding or things like that. But they're actually pretty costly and can be pretty traumatic on homeowners. As the basement gets flooded, they lose their valuables, they have health problems from mold and mildew and so forth. So, and it's this trifecta of wetter climate and an aging infrastructure and urbanization, which increases the runoff. And that brings up a point on all this climate change issues that, these things aren't happening in isolation. It's not that we're just getting more rain and that's all there is to it. It's that we're also having all these other changes. So we've become more urbanized in some parts of Illinois. We've got infrastructure that's maybe was designed 50 years ago, the bridges and the sewer lines and the storm sewers. So there's a lot of things that are happening together that make this problem much more challenging as we face this down. Soil erosion is another problem in Illinois, especially since we have so much agriculture in the state. And the way we do it is we do a lot of corn and soybeans, which is a warm season crop. And so a lot of times I have bare fields in the wintertime. And that's when you get these heavy rain events that can cause quite a bit of erosion. We can mitigate that by things as simple as grass waterways and cover crops and things like that. So there are methods out there that if we use them more, we can at least reduce some of the damages caused by this. Oh, and I'd also add too that not only are we getting soil erosion, but you get nutrient loss off of these fields and gets in the rivers and streams and lakes, and that can cause problems farther downstream. So switching gears slightly, but speaking on the same subject on a more regulatory side, one of the things that we do in Illinois and elsewhere is that we actually have design regulations in place to at least attempt to address the issues of flooding from stormwater. So part of those regulations are wrestling with concepts like the 100-year flood or the 100-year storm, and try to design structures that can handle those kinds of events. And the problem is that those numbers have changed over time. So if you've done an analysis 100 years ago, we're in a drier climate, your expectation of what a storm once every 100 years would look like is much lower than it is today. In fact, it's about doubled in some areas. So because of these big changes, we have many of our structures that are out of date in terms of their ability to handle stormwater, and we're trying to play catch up. So we have introduced new studies. In fact, the newest one just came out earlier, I guess last year and this year. We've kind of rolled out some studies that have updated the regulations in Illinois. So as part of that study, we'll get into the weeds here just a minute. So when you have, I mean, one way to do a study of what's the frequency of a 100-year storm is you take 100 years of data, you plot them all up and rank them, and the biggest value is your best estimate of your 100-year storm, your next biggest value is your 50-year storm, and so forth. And then you can actually fit a distribution to those and come up with some, what you hope are reasonable estimates of what all those likely storm events look like. Well, historically, we just took whatever data we had and we ran the numbers and came up with the results. In this last study, we realized with climate change in Illinois, if you use the earlier data, it was going to bias the amounts on the low side. So we made the command decision in this case to drop any records before 1948 and just use the post-World War II records for this analysis. Now, it also gave us some other benefits. It gave us a lot more stations. In Illinois, there's about 3 times as many stations after World War II. But the point is that we're getting to the point that the climate is changing so much that we can't just rely on the historical records to be a guide for what's going to happen in the future. Because keep in mind, when we're building these structures that handle stormwater, they've got to last on into the rest of this century, basically. So we not only have to build them for what's happening today, but what's going to happen in the future. So that has been a big problem and a big challenge in trying to basically predict what the future extreme events are going to look like. And to do it in a real world basis where somebody pouring concrete for the stormwater sewer can get their order right. So this is, on the left-hand side is the old Bulletin 70. This was done about 30 years ago. And I'll just highlight there for the northeast part of the state, the 24-hour 100-year storm is 7.58 inches. And the new one, it's 8.57 inches. And the really old study that came out in 1961, that value was, I think, about 4.87. So it's gone up an inch just in the last 30 years or so, the estimate of that extreme value. Now, an inch by itself doesn't sound like a big deal, but after you get about the first inch or two of precipitation, pretty much everything else will run off, all things being equal. So getting an extra inch of rain in a heavy rainfall event, that means that all of that inch is pretty much going to end up in your basement or a storm sewer or out on the street. We did some research in the area to look at future increases in these heavier storms, the 100-year storms, and it's just to have a snapshot of a long report on that. But the takeaway there is that we were seeing the potential of another increase of 25% by the end of the century. So basically what we're saying is that what we've seen so far, that trend is likely to continue on into the end of this century. So even today, we're struggling to design things and build things that can handle future stormwater in Illinois. Well, that's a lot of bad news, maybe some good news if you don't like drought. So Illinois drought history is, this is the Palmer Drought Index. It's a long-term index that measures drought in Illinois. If you're in the blue, that means it's wet. If you're in the red, it means it's dry. Before 1965, we had several major droughts in Illinois. We had some in the 1915, 1934, 1936. 1954 was a big one, a multi-year drought there, and some intense ones in the 1960s. in the last 30 or 40 years that we've had fewer droughts, and the droughts that we've had have been shorter. Well, we thought 2012 felt like the end of the world. It really wasn't that noteworthy compared to some of the earlier droughts. The 1934, 1954 droughts were much more intense and much longer lived than the 2012 drought. So we're in a different drought climatology. Remains to be seen if that will continue on into the future. That's one area that with climate research, they're still debating on whether or not it'll go one way or the other. I would say in the short term, I'd say that our risk of long-term drought is probably less because of the wetter trends, but we can still have some droughts sprinkled in here and there. Here's our average temperatures. We've warmed by about 1.2 degrees over the last century. So like I said, compared to some other areas, it's not quite as dramatic. But if you look at the last, especially the last 20 years of the records, those are the warmest decades in Illinois history, in the written history records. So 1930s, yes, they were warm, but overall, the last 20 years or so have been the warmest. One thing that has happened in Illinois is that we've seen is summertime temperatures. It's a bit of a quandary here in that the daytime high temperatures really have not warmed up that much. In fact, they've been going down a little bit, so we've been moderating those. Nighttime temperatures have actually climbed upwards. I think part of that is that since we are wetter, we're getting more rain, we're getting more cloudy days. All of those work to keep the daytime high temperatures lower. So if it's cloudy, if it's really humid, if you had a lot of rain recently, you'll get a lot of steamy days, but you won't get a lot of really high temperatures. And we really have to be in drought conditions in Illinois to get in the 95 to 105 degree range in Illinois. So, we haven't had as many droughts. It's been wet, so that's held down those daytime temperatures. But nighttime, it's humid, so it's harder for it to cool off at night. So we're seeing the nighttime lows increasing over time. So that's an interesting effect that we might not have take away from just the overall trend of us getting warmer. So there is some complexity in these seasonal patterns here where temperature and precipitation interact with each other. So this is average snowfall. I just want to show this real quick. I don't have the latest year or two on here, but surprisingly, snowfall in Illinois, first of all, we're not that snowy of a state. We did have a lot of snow in the late 70s, early 80s there. You can see that spike on the graph. But otherwise, we have a lot of variability from year to year, but no real long-term trend. So that's one area that we have not seen play out yet, where the snow has disappeared in Illinois, although it does tend to not stick around quite as much as it did in the early to late 70s there. I want to mention one or two other things here real quickly. One is what we call a false spring. That's when you have really mild winter weather. You get a couple of warm days in February and March, and suddenly the trees are starting to leaf out, and you see trees blossoming. I can see some out my window right here. And then you get a frost, and the frost then sets the trees back, so the shrubs back. And in some cases, from an economic point of view, you got peach and apple crops. You can actually lose those crops in these situations. And we had this problem back in 2012 and 1997. There are actually billion-dollar losses in the fruit industry. This is a map from the National Phenology Network right now. And you can see down in the south there's several weeks, about 14 to 20 days ahead of schedule on the leafing out. Here in Illinois, we're kind of close to the long-term average on the leaf out. So we're not in too bad a shape. But there is forecast for cold air to come in to the Midwest in the next couple of days, so that some of those areas could be vulnerable to frost. So that is kind of one of these other odd side effects that we talk about, overall warmer conditions, but you can still get cold air outbreaks during that. So we might actually see more of these kind of events moving forward. And of course, the other not so favorite thing with this is that we're not bringing in invasive species in Illinois, and also the species we already have may also thrive in a warmer, wetter climate as well. Mosquitoes probably the number one concern there, but also ticks and all kinds of invasive species that the cold weather would normally keep in check now can run loose with these milder winter conditions. So we may see not only the landscape change, but also what we see in the landscape change. And I always tell my armadillo story a long time ago, probably 20, 30 years ago, you started to see reports of armadillos in far southern Illinois, down around Cairo in that area. Let's see, about 2 years ago, I saw an armadillo roadkill. I don't know, kind of hard to, near Effingham. That was about 2 years ago. And then in the last year or so, we've had reports of armadillos here in Champaign County. So armadillos normally are something in Texas and Arkansas and places like that. So they're actually migrating northward. So it'll be our new state animal here in a couple of years. So it just kind of illustrates how things have changed right under our nose in terms of the invasive species. I want to talk just a second here before we wrap things up here about, we talk about long-term climate change in the past and in the future. We also do what we call climate monitoring, which is observing what's going on right now. So we have a whole suite of instruments. This is an automated site that you might see at an airport. We have several networks out there that monitor climate conditions around Illinois and around the U.S. And so you can use that to put things in perspective, put recent events in perspective. So, for example, here's basically the winter months, December, January, and February across the United States, the temperature departures. So you can see that this winter, for most of the U.S., was actually quite warm. Many places were 2 to 4 to 6 degrees warmer than normal or average for the winter months there. So it was really a mild winter pretty much everywhere in the United States, except for the Rocky Mountains. Also, the precipitation we've had in Illinois, we had this band of heavy precipitation, especially in the southern half of the state that extends all the way back to Kansas and on into Indiana there. And in the southeastern U.S. has also been very wet. So there's some dry spots across the region, but for the most part, we've had a very wet winter. And a lot of that fell as rain instead of snow. And these are all conditions monitored by the National Centers for Environmental Information. And they do monthly reports on this. This is USGS. I just grabbed something off their website showing the stream flows. This particular graph just shows those gauges that are in flood stage. So we've got basically the Missouri, parts of the Missouri, the Mississippi and the Ohio there at down in southern Illinois that are in flood stage right now from all the rain that's happened over the last 30, 90 days there. So, and most of the streams in Illinois are very running on the high side for this time of year. And there's the U.S. Drought Monitor. Hopefully some of you have heard of this. This is the national map for monitoring drought conditions across the U.S. Look at rainfall, stream flow, soil moisture, crop conditions, wildfires, and so forth. Try to summarize drought conditions across the U.S. in one map. You can see the Gulf Coast right now is suffering from drought and also drought out in the western U.S., but the Midwest is drought-free. It has been drought-free for some time. I think probably have to go back to sometime in 2017 or 18 to actually have seen drought in Illinois. It's been a while. But these are the kind of things that you can look at if kind of more of an operational climate monitoring scale as you do your operations. So in summary for Illinois, we're really getting warmer throughout the year, especially wintertime temperatures have probably been the most pronounced there. And there's a concern moving forward with higher summertime heat as we get warmer moving forward, by mid-century, 4 to 5 degrees warmer, late century warmer than that. So I'm sure that the case of us having the milder summertime high temperatures at some point is going to go away. But I think overall, the really key factor is the overall weather conditions with the more frequent and heavy rain events. And I'll stop at this slide because I thought this was an interesting one. When I talked to climate scientists on Twitter and things like that we see some amazing parallels between the current pandemic and climate change issues and how people respond to them or don't respond to them. Climate change is a much bigger issue on a very long time scale, but it's really, this pandemic is pretty much, in a nutshell, what we go through with the climate change in terms of not knowing what's going on, doubting what's going on, the question, what do we do? And they get conflicting results based on your political affiliation and so forth. And it's really kind of, it very nicely summarizes that. And also the fact that what we want to do with climate change is flatten the curve. It's the same concept. We just want to do it for a different problem. So with that, I'll stop, and I think we have time to field some questions.
Thank you, Jim. That was a great way to get things started for us today. A reminder to all the attendees, if you look on the lower part of your screen, you'll see a Q&A button. You'll be able to type in some questions there if you have any. And Doug Blodgett from the Nature Conservancy will be moderating those questions and asking them of Jim. So Doug, we have a little while that we can field some questions, so I'll turn things over to you.
Thanks, Tom. Thank you, Jim. That was really great. We have a question here. The use of cover crops could help with several of these problems, many of the problems that you stated, as well as some others, but especially soil erosion. And do you have a feel for why we're not seeing more use of cover crops?
You know, that's a good question. I've pondered that over many a drive across Illinois over the years as part of my job and seeing relatives and so forth. And yeah, I've never quite understood why that's been so slow to catch on. I mean, I know there's operational issues, part of it may be out of habit. And you know, it's a different mindset, and there are different issues you got to address. But it seems, especially in some areas that are more prone to erosion, that yeah, that would certainly be attractive to have some kind of cover crop. And I think there's still in the. I think there's just a lot of resistance to it, and I'm not exactly sure why. I wish I had a really good answer for that. There are some programs in place now and have been expanded a little bit. I think in Illinois they've threw a little more money into cover crops. I think the state has a program where you can get so many dollars per acre if you use cover crops. And you know, that may be the way that we have to go, is that that farmers get some kind of direct payment for those kind of things. And you know, maybe that's part of the problem, is that maybe the connection between reduced soil erosion and having to mess with cover crops is so far away from, I got to make a crop for this year to pay pay the bank. So there may be a lot of short-term pressure on farmers, especially right now with the farm economy, that it's hard for them to think long-term.
Good. Here's one that touches on part of that, with the idea of marketing these ideas and maybe marketing some of the solutions. In terms of the parallels with the recent action on COVID-19, do you have suggestions regarding effective science communication to help move us forward in planning and acting on these issues of changing Illinois climate?
Yeah, that's a very good question. That's one of the conversations I've been having with other climate scientists is what can we learn from this on what to do and what not to do on climate change, because it's an uncanny parallel to these. I mean, we talk about the risk, and not only risk right now, but future risk and compounding problems and so forth. And it's just very much the same thing. So I think scientists will probably will learn from this, and as well as the general public. I think they'll expand their knowledge as well. I think one of the things that we've seen is that the science literacy in the United States is pretty depressingly low. And so when you discuss some of the more, if you discuss anything that isn't super simple, then it just goes over the head, or they quickly write it off. So those are some long-term challenges that go beyond just communication, but actually education. But yeah, I'm sure we'll be learning a lot more from as far as effective science communication goes.
Good. Yes, it seems like lag times are really a challenge for us in both of these crises. That it takes a while for people to get up to speed, both from our outreach efforts, from our communication, but also for them to see what's really happening. We predict these things, but until the public actually sees it, it seems to be pretty tough to get everybody on board with making a change.
That's
Good.
right.
What, someone asked for clarification. With the increase forecast in precipitation, that won't come primarily in the form of snow. It would be liquid precipitation. Is that correct?
Yeah, I think over the long term, that's the thinking is that in the wintertime, the precipitation will come more likely in rain rather than snow. That doesn't mean we still won't have snowstorms and things like that, but they will probably be longer lived. Now, they might be, in some cases, we might actually get some storms that could produce more snow because the atmosphere is more moist. And as you get close to the 32-degree range, that's when you usually get your biggest snow producers. So that one's a little complicated just because there's temperature and precipitation factors that come into play. But overall, the expectation in the future is that we'll see the increases in wintertime precipitation will come primarily from the rainfall events and not snowfall.
And then as we look out even further, looking out centuries instead of decades, is there some mechanism that's going to solve this problem for us in a way we don't like if we don't solve it?
Yeah, that's an interesting question because, we kind of always, most of the discussion has been on mid-century, late century. It obviously gets harder the farther out you go because it's harder to predict how society will respond even out to the end of the century. So you don't know if they're going to do well or not do well on mitigating climate change. So I think that's why there's not been much discussion farther out. Now you could imagine a scenario, and this is probably the worst case scenario, is eventually we empty out all the fossil fuel reserves and put them back into the atmosphere, and so we have extremely high levels of CO2 in the atmosphere, and we just totally change the planet into something that would not even be recognizable today. That's one scenario. I don't think we would get there. I think the impacts will be so severe that it'll that we won't go that far. But it is highly uncertain how things are going to play out longer term there.
You showed a graph that indicated that carbon dioxide levels changed pretty dramatically in the 70s and 80s. Was that also due to a variety of circumstances or causes, or can we attribute that primarily to one or two things?
Yeah, I think what's happening overall is just that the U.S. and the world economy is just growing faster and faster. If you think of like 1970, there, we always talk about first world countries, and it was primarily the pollution or the CO2 emissions from that time period were coming from places like the United States and Europe and Russia. And now you look at it, and now we've got China came on board a couple of years ago as being or several years ago as being a major emitter of CO2 gases. And, we've got India, another billion people there that are moving towards a more modern standard of living. So there's just more and more people and more activity in those levels. So that's all driving up these CO2 levels. So it has been increasing more rapidly in the last couple of decades, as opposed to like the 1800s, where it was pretty limited.
Good. What about the role that tile drainage plays in higher water levels? Have those been teased apart?
Yeah, there's quite a bit of research done on that, especially in Iowa. Iowa had, I think it was 2008 and 2009, they had, as well as 1993 and a few other years, they had quite a bit of trouble with flooding there. And so there was a lot of research done on tile drainage, and it does aggravate river flooding in that you're taking the water off the fields too quickly and dumping it into the rivers and streams. And so you get that, it almost turns it into an urban area in terms of its response to the heavy rain events. So the idea is that what you really want to do is slow all that down. So one way to do it is if it's in the wintertime, you have cover crops. You also can add grass waterways and other things that especially at the end of the field, to keep the water in place at least for a little while, and then slowly release it. I know there's some places here in Illinois that have the valves at the end of at the end of the fields where you can operate to open and close the tile drainage. I mean, it used to be they just put in tile and it just was free flowing. So by having some control over that, not only does that reduce flooding, but in some cases you may want to hang on to some of that water for the rest of the growing season.
Decades ago, we had a lot of hedgerows planted for a variety of purposes in Illinois and in other states. And we see over the last few decades, a lot of those hedgerows have come out for a variety of reasons. Do you see any potential for hedgerows to contribute to some of these negative impacts of climate change?
Yeah, I think the hedgerow issue and windbreaks in general, and it was probably a bigger situation, a bigger effect out in the plain states where they have high winds and very dry conditions. So the soils were much easier to move around in those situations. We get that every once in a while in Illinois, especially in the springtime after everybody's tilled in the fields and kind of stirred the dust up a little bit. So you do see some soil erosion or wind erosion in Illinois. It's not nearly as bad as it is in those western states. But yes, unfortunately, a lot of those windrows were taken out, or windbreaks were taken out in the 50s and 60s, well, probably in the 60s and 70s and 80s as we went to bigger and bigger farms. So that's, I talked to my counterparts out in Oklahoma, and that is a problem out there, is that they've, in some places, it looks like it did in the 1930s during a drought.
Doug, you're muted right now.
I think that's the questions that have come up on the Q&A box. Any of the organizers have any other questions to ask Jim? If not, I think that's it for the Q&A. Thanks again, Jim. That was very insightful, and we appreciate you kicking off our 14th symposium.
Yes, thanks for having me. And like I said, I'm happy to share these slides with anybody. I'm not giving away any state secrets or anything. So if you're interested